Okay, I've had a couple of mishaps in recording this video, so this is the last time I'm not recording it after this one. So you might hear some mistakes, but basically I would always try to correct myself. Okay, quadratics. I'm pretty sure you've heard about quadratics before. Somewhere, maybe in our study of polynomials or in school, or someone mentioning it, saying it's difficult. You might also have heard about the quadratic formula. It's quite a popular concept in math, having to deal with quadratics, which basically refers to polynomials with degree of 2, right? So x squared is equal to something, x squared plus something x plus all of those. Um, so we'll be considering in this video, we'll just be learning about what they are, just to give us a bit of a background, what to expect when you try to find the solution to a quadratic equation. We'll look at the graph, the function, what to expect when you try to graph a quadratic function, and so on and so forth. Okay, so for solutions, when you're dealing with x squared, say you had x squared is equal to whatever, maybe 10. X squared is equal to 10. So let me write that somewhere. X squared is equal to 10. You want to take the square root of both sides, right? So you would say x is equal to square root of 10. So what I'm just trying to drag out from this is that whenever you have to find the solution to a square number, you would take the square root. And I believe you should be familiar with that by now. In that light also, whenever you have to solve a quadratic equation, you would always have to take the square root of a number. Whether you do it by actually taking the square root or you're using some other trick, but you usually have to take the square root of a number. And this gives us an insight into the number of solutions we could have when we try to find or solve a quadratic equation. So I've painted 3 scenarios here. The first one is when you have a positive number. Second one is when you have a negative number. Third one is when you have, 0, basically. So somewhere within your solving, you have to take the square root of a number. And if the number is positive, then when you take the square root, so let's use 9 as our case study, like I have done here. If you take square root of 9, you would have x is equal to square root of 9. So x is equal to, the first thing that will jump out of your mind is that x is equal to 3. But then you also want to remember that x can also be equal to negative 3. The reason why is because if you square 3, you get 9. Square negative 3, you also get 9, yeah? So basically it makes sense to say that the square root of 9 can be 3 or negative 3. This word or and positive or negative would be all over this course, so it's something you need to get used to. That's the first scenario. Take the square root of a positive number, you could get 2 solutions. Next, we have square root x squared is equal to negative 9, and maybe you get stuck here, square root of a negative number. What do you do? Would have x squared is equal to, or x squared is equal to negative 9. So x is equal to the square root of negative 9, yeah? Take the square root of negative 9. You can do it on your calculator. You will get no solution, and I will explain why. No solution. The reason why is because the square root of a negative number, there's no number that could, no real number at least, that could, that you could get as a solution to that. It can't be 3, obviously. It can't also be negative 3 because negative 3 squared is also 9. So in that sense, you could say positive numbers have taken the square roots of the square roots that can both be positive and negative, and so basically negative numbers are left with nothing. You could try this on your calculator. You could see no solution or undefined, something like that, or math error. So scenario number 1, scenario number 2, scenario number 3, we have x squared is equal to 0. So if you're solving and you get stuck somewhere here, x squared is equal to 0, you take the square root. X is equal to the square root of 0. So that means x is equal to 0, and so you would have one solution. Right? You would have one solution. So when you take the square root of 0, if along your way you have to take a square root of 0, you would know that, okay, you know what, my solution, I'm going to end up with one solution. X squared is equal to 9, 2 solutions, right? In brief, quadratics can have 0, 1, or 2 solutions. Quadratic equation. All right. The next thing we'll look at is we'll just look at the graphs and some key properties of quadratics. Okay, so the first thing to note is that a quadratic equation will have a degree of 2. Of course, we said that already, x squared, right? So degree of 2. It could have 0, 1, or 2 solutions. We've discussed that, and we'll discuss that a bit later on also. So it's going to be all over this course, being conscious of the fact that you could have 0, 1, or 2 solutions to a quadratic equation. The next one, and this is where it gets interesting, is a parabolic curve. When you graph a quadratic, you don't get a straight line like you did in linear equations. You get, or linear functions, you get a parabola. That's a curve. So the curve could either be concave up or concave down. We'll discuss that in a bit, but you will get a curve. It's more like a cup, a perfect cup in a sense, and it goes for all of, for all. It continuously just keeps on going on and on, right? Okay, what are some other interesting things? Okay, as is with any graph, you should be familiar with this by now also. We would have intercepts. That's, you would have intercept. Intercept basically mean where your graph cuts the axis, yeah? They mean a bit more. We'll discuss that in later videos. But for the sake of this, we could have 2x intercepts. At least this one has 2x intercepts. Because that's basically where it cuts the x-axis. And then this one here is also your y-intercept, because the line also cuts the y-axis here. So you want to look out for your x-intercept and your y-intercept. Okay, let me mark out the intercepts here again. This and this are your x-intercepts, and then this is also your y-intercept here. This point here, 0, is both your x and your y-intercept. Okay, another thing you would always see everywhere in this course would be the solutions, roots, zeros. I would use them interchangeably, so they all mean the same thing. That's all I'm saying. So like for this now, your solutions are 3 and -3, right? Sometimes we call them roots, sometimes we call them zeros. The idea is that they are also your x-intercepts actually. Just remember that. They are also your x-intercepts. So let me just mention this here, even though we'll do it a bit later. That is the fact that the values you have here are also the same answers you get as your solution to your quadratic equations. And later on in the course, we'll learn why. So these are also your x-intercepts. Sorry, your x-intercepts are also your solutions. So some people say, if you want to solve a quadratic equation, you could just graph it and then pick out your x-intercepts. And you'll be right, because those will be your solutions to the equation. Finally, we have a vertex. For me, this is the most important part. You know how the slope was really important to linear functions? In the same way, your vertex is really important to your quadratic equations, or quadratic functions rather. And the reason why is because it gives you, well, again, for me, the most important information about the graph. Quadratic functions model scenarios that could see a decline going down, hit a minimum, and then start going up, right? Or could model scenarios that rise to a maximum. This was the minimum for this one. So rise to a maximum and then begin to drop again. So for whatever this thing models, I feel like one of the things that would be most important is this point here. This point, your vertex, for me, again, is the most important point. And we'll be looking at how to find those from a graph or from an equation. Your vertex can be a maximum or a minimum. If it's concave up, if your direction of opening is up, then your vertex would be a maximum. So this is a maximum vertex. If your direction of opening is down, your vertex would be a minimum. I just made a mistake. Okay, let me take that again. I meant to say your vertex can be a maximum. So let's look at that. Here we go. I almost thought I was going to get away with that statement of saying I would make a mistake and all of that. But anyway, your vertex is a minimum if it's concave up. Right? So you can see your vertex is at the minimum here. and then your vertex is a maximum if it's concave down. Okay, so those are basically, I know it's a lot. You might want to watch this video again. Right after this, there's an interactive basically that you can click on to just see the properties of a quadratic graph that I put down there. Okay, a bit of a recap before we round it up. We said a quadratic equation can have 0 solutions, 1 solution, or 2 solutions. We said you would have 0 solutions when you have to take the square root of a negative number, so look out for that. You would have 1 solution when you have to take the square root of 0, and you would have 2 solutions when you have to take a square root of a positive number. So it's really important that you hold on to this. We said quadratic equations or functions have a degree of 2. You could have 0, 1, or 2 solutions. It has a parabolic curve. It has intercepts, so 2 intercepts on the x, or 0 or 1. We said your x-intercept also means your solution, roots, or zeros. And it has vertex, which I have said for me is the most important, and we'll be looking at a bit later on. All right, thank you very much for sticking around, and bye-bye.